Hello everyone, thank you for watching this video today. In this video, we're going to start talking about the properties of logarithms. Now, we've already talked about a few of these properties before, namely these first two. We've talked about those in depth in our last video. Okay, but now we have a couple new ones that are extremely important in the simplification of logarithms and solving logarithmic equations, which is where we're headed soon. Okay. So basically, if we take a look at these four new properties, we see if we have logarithm of two numbers that are multiplying, could be two functions, could be a function and a number, could be anything. We can split that up into two different logarithms, and we add the logarithms together. Okay. Conversely, if we have two numbers or two functions that are dividing each other, okay, we subtract, but I don't want you to think of it as we subtract. Basically, anything that's in the denominator, we can move to its own log with a negative logarithm. Anything that's in the numerator, we move to its own log with a positive logarithm. Since both of these are in the numerator, that's why they both get positive logarithms, okay? The next one, if we have a function being raised to a power inside of a logarithm, we could take that power and bring it out in front and multiply the logarithm by that number. And the last one, which is extremely helpful in calculator problems, the change of base formula. Why is it helpful in calculator problems? Because our calculators, most calculators only have the ability to do two different log bases, log base 10 or log base e, okay? So if we have a problem that we're doing with our calculator and we have a different log base besides 10 or e, we can change it into e or 10 by simply doing one of these. So log base u of v, we can do log of v over log of u, or log base e of v over log base e of u. So let's take a look at how all of these properties are used as we go through today. First one says use of properties to expand each of the following. So the directions a lot today are either going to be expand or condense. All right, so this first one is expand. So ln of 7x. We can rewrite this as ln of 7 plus ln of x. Both 7 and x are in the numerator, so we both get positive logarithms. Second one, 10x and y are all in the numerator, so all three of them can get their own logarithm, all positive logarithms. And we can go one step further, because at this point we should know what log of 10 is. Remember, this is log base 10 of 10, which is 1. So we can write this as 1 plus log x plus log y. Third one, 19 in the numerator, so that means it gets a positive logarithm. X is in the denominator, so it gets a negative logarithm. So it's log base 7 of 19 minus log base 7 of x. And we don't know what this is, so we can leave it just like that. Number 4. So we have natural log of e to the third minus natural log of 7, which then I can rewrite as 3 ln of e minus ln of 7. And ln of e is 1. It's log base e of e, so it's 1. So I can write this as 3 minus ln 7 as my final answer. Number 5, ln of x squared. The 2 can come down in front and multiply, so it's 2 ln x, and we don't know anything there we can simplify, so that's it. 6, this is a trick that's going to be used a lot in your future math classes. We need to rewrite the root as an exponent. Root x means x to the 1/2. And now I can bring the 1/2 in front, so it's 1/2 log base 2 of x, and that would be our most simplified answer. Next slide, we're going to put a couple properties together on each of these problems. So number 7, everything here is in the numerator, so we get a lot of positive logarithms. So log base b of 2 plus log base b of x squared plus log base b of y. And then here, we can pull that 2 out in front there. So I can rewrite this middle term as 2 log base b of x. And that would be our most simplified answer for this one. Next one, we have one thing in the numerator and two things in the denominator, so they both get negative. So it's going to be log base 6 of third root of x minus log base 6 of 36 minus log base 6 of y to the fourth. All right, so a couple things we can do, actually three things we can do here. First of all, I can rewrite that first term as log base 6 of x to the 1/3. And I'm just copying down the rest of it here. Now we can do lots of simplification. So this would be 1/3 log base 6 of x. Log base 6 of 36. 6 to what power is 36? That's 2, so minus 2. Minus the 4 can come out in front, so 4 log base 6 of y. And that would be our most simplified answer here. Number 9. So we have four factors here that we can split into four terms. 2 are in the numerator, 2 are in the denominator. I'm going to start doing a couple things at once here, so hopefully you can follow along. Log base 2 of 5 plus log base 2 of x to the 1/2 minus log base 2 of 2 minus log base 2 of y cubed. Log base 2 of 5, we don't know what 2 to the 5, 2 to what power would give us 5 here, so that is just going to stay how it is. The second one, we could bring the half down in front. Log base 2 of 2, 2 to what power is 2? That's just 1. And then bring the 3 out in front for this last one here. And that would be our most simplified answer for this expansion. All right, last one here. So again, we have two factors multiplying. Both are in the numerator, so both get positive. Both get positive logs. So it's going to be ln of x squared plus, I'm going to write this as ln x cubed plus 2 to the 1/2. Both exponents can come in front, so 2 ln x plus 1/2 ln x cubed plus 2. That is it. We cannot go any further. A huge mistake I see all the time is students want to rewrite the second one as ln of x cubed plus ln of 2. You can't do that. You cannot distribute a function, a log function there like that. So that is as far as we can go. Okay? Number 11. Let A equal log 3 and B equal log 6. Write each in terms of A and B. So we're going to use our rules here that we just kind of been using to first split this up. So 18, we want to get everything in terms of 3 and 6. If we can get everything in terms of 3 and 6, we're in good shape. So this would be log 3 times 6, which I can rewrite as log 3 plus log 6. And now we have A plus B, which is what we want. Second one is log 6 squared, which is 2 log 6, or 2b. Third one, 54. We can rewrite that as log of 9 times 6, which is log of 3 squared times 6, which is log of 3 squared plus log of 6. Almost there. 2 log of 3 plus log of 6. And finally, 2a plus b. Log 1/2 I can rewrite as log 3/6, which is log of 3 minus log of 6, or a minus b. Log of 2 I can write as log of 6 over 3. So that's log of 6 minus log of 3. So that's b minus a. And log of 1/3, I can rewrite as log 3 to the negative 1, which is negative log of 3, which is negative a. All right, going backwards this time, we're going to condense. It's currently in expanded form. We want to use our properties to bring us back into one logarithm method. When we're done here, we should have one logarithm in our answer. So since both of these are positive, I can rewrite this as log 25 times 4, which is log 100. And we can now even go further than that, because remember, that's 10 to what power would give me 100, and that's 2. So that original problem becomes 2. Second one, log, the 7x minus 6 is positive, so it goes in the numerator. The x is negative, so it goes in the denominator, and that's as far as we can go. So that's good enough for that one. 14, I can rewrite this as log root x plus log x minus 1 to the 4th. And that becomes log of root x times x minus 1 to the 4th. (15), I can write this as ln x plus 7 to the 3rd minus ln of x, which then becomes ln x plus 7 to the 3rd over x. (16), log base b of x to the 4th minus log base b of 36, right? 6 squared is 36, minus log base b of root y. And now one big logarithm, x to the 4th goes in the numerator, and then 36 root y in the denominator, because they both have negative logs. Last one. So the first three terms are great. We have 3 log base 3's, but the last one we don't have a log base 3, to 2. So what we're going to do is we're going to multiply it by log base 3 of 3. Why are we allowed to do that? What is log base 3 of 3? It's 1. So now we have all of our logarithms with a base of 3. And now I can rewrite this as log base 3 of 4 minus log base 3 of x squared plus log base 3 of y to the 5th plus log base 3 of 3 squared, which is 9. And now I can condense it where these 3 go in the numerator and this one goes in the denominator. So our answer here is log base 3 of 4 times 9, which is 36y to the 5th over x squared. All right, our last one here today is the change of base formula. So remember, we can use log base 10 or ln if we want here. Find the value of log base 3 of 17. I tend to always use ln. I don't have a very scientific reason behind it. I use ln because writing ln is one less letter than writing log. So ln 17 divided by ln 3, and this is a calculator problem, so if you need to pause the video here to get your calculator, I'll do that now. Type in ln of 17 divided by ln of 3, and you should be getting approximately 2.579. All right, so if you want to pause this video here and try the 3 problems that we see here, you're welcome to do that. Otherwise, I will go through them right here. So 19a is ln 85 over ln 6, which is 2.479. Part B is ln of 2/9 over ln of 5. Negative 0.935 is what I'm getting here. And the last one is ln of e over ln of root 2. Now I know ln of e is 1, so this is 1 over ln of root 2. So 1 over ln of root 2, 2.885. All right, so that will do it for our lesson today on the exponent properties. These are very, very important properties to remember if you move on to pre-calculus or higher levels of math. I hope you learned something today. Thanks again for stopping by, and we'll see you again soon.